This screencast is about significant figures, sometimes known as significant digits, and how you determine if a digit or if a figure is significant in science. All right, what's a significant figure or significant digit? Well, sometimes I like to open this discussion by saying in math class, you could look at math class as being a bit of a perfect world scenario, where if you see a number like 0.138, you understand what that really means is that it's 0.13800000000000000000000 on and on forever. Okay? In other words, it's kind of like perfect. We assume there's like perfection with a lot of this work we do, okay? That it's like totally precise beyond the measure of any like measurement instrument, okay? We work in the perfect world in math often. Whereas in science class, we have to presume that we only record what we are certain of to a certain degree, okay? So in science class, 1.38 means 1.38. It means 1.38, and then we don't know what comes after that 8, because presumably this is a measured data point, a measured value, and we couldn't measure all those digits of precision beyond, in this case, the thousandths place value, right? So in science, when we write 1.38, when we write 0.138, we mean 0.138. We don't know what's after it, and we can't just add zeros forever. It's the real world, not the sort of perfect world. All right, so here are the rules to determine whether or not a figure is significant. All right, so follow along with these 3 basic rules, and that'll get you most of the way there. Okay, so first rule is that non-zero digits are significant. So any non-zero digit is always significant. If you look at these examples, you would have, in the case of 141, that tells you you've got 3 significant figures. If you look at 1.41, it also has 3 significant figures. Or if you look at 14.1, that's 3 significant figures, right? We've written each non-zero digit, and that makes it significant unto itself. Anything not written is not significant. So the fact that there are not zeros trailing, right here, we didn't write zeros here. You presume that we don't know those digits. Okay. The second rule is that a zero between non-zeros is significant. Okay, so this rule right here is telling us that if you have a 0 sandwiched between non-zero digits, like in the case of 10401, that's 10,401, that would be 5 significant figures. Likewise, even no matter where the decimal is, so if it's like 1.002, then that's a 4 significant figure number, okay? The third rule is, moving down to number 3, that a 0 after a non-zero may be significant based on the context. So this one you kind of have to apply a little bit of logic and a little bit of context. And ideally, we want to make it clear by using the decimal. So I'll show you in a second. But if you're given a value like you see right here that says, okay, there are 300,000 people in Victoria, British Columbia, it's actually ambiguous. It's not clear how many significant figures you should regard in that number. Is it 1? In other words, did they round to the nearest 100,000? Or is it 2? In other words, do they know that number to the nearest 10,000? Like, are they really confident about the 0? We don't really know. Or is it 3? Did they round that number to the nearest thousandth, right? You should try your best to make that clear by inserting a decimal. So what do I mean by put the decimal there? Well, I'm going to emphasize this by making it really clear. But if you put a decimal place, so check out these ones over here on the left here. If you put a decimal place there, even though you've got 0 digits after a non-zero, the decimal at the end here makes it really clear that this is meant to be a number regarded as 3 significant figures, okay? By putting the decimal there, you're making it clear that both those zeros are significant and we know them, right? in the next one down there, you can see they've put the 0 there. And since they've included those non-zero, those 0 digits after the non-zero, clearly they're significant. Otherwise, they wouldn't be written there at all, right? So this is also a number with 3 significant figures. Another way then to express something like the population of Victoria and actually expressing it with precision to a precise number of significant figures would be to write it like the way they've written it there, 3.01 times 10 to the 5 people. So scientific notation can really help make it clear in this case that also has 3 significant figures. So if you go back and apply that to what that means to the original value, it means that like these ones were kind of unknown, all right, but we were confident to the thousandth, to the thousands place. Sorry. Okay, so how about processing values and keeping track of significant figures when you process? So the first processing rule, so I can write that up here. This is processing. Okay, the first processing rule is that if you're adding and subtracting values, like you are right here, okay, 8.314, that's a value with 4 significant figures, right? 4 significant figures. This value, 1.4, only has 2 significant figures. Well, the rule is you actually go with the fewest decimal places presented, okay? So the answer to that, if you do the processing here, is 6.914. But what you should not do is you really shouldn't present the final 2 because you don't know what these values were here. And by presenting them, you're presuming there were zeros there, but you don't know that there were zeros there. So what you do in actuality is you do not present those last 2 figures, and you just present this as 6.9. So it's like the number of decimal places ends up determining the number of significant figures. And so in the end, you're down to 2 significant figures for that answer because you had 2 significant figures and 1 decimal place in that one value you used. On the contrary, maybe not technically on the contrary, but a different system is when you're multiplying and dividing, you look at how many significant figures are given in each value. Okay, so this value has 4 significant figures, and this value has 3 significant figures. If you're not sure how we assign that, go back and look at the rules for assigning significant figures and do some of the practice on that, and it'll become a lot more clear. But for multiplying and dividing, the rule is you just go with the fewest. So you go with the fewest significant figures, or the least significant figures given in the values. Given in the values. So in other words, we've got a 4 and a 3. We want to present the final answer to 3. So if you do the math on this, you end up getting like 50 point. If you just punch it in your calculator, you'll get a mess of figures, right? It's all far too many figures to present. 50.05028. What you want to do is just round that to 3 significant figures. So you would round this to 50.1. Okay, so you'd present your final answer as 50.1. That has 3 significant figures, which is the least that were given in those 2 values you originally processed.